All right, we're looking at the lesson 3.1 for Math 2, the big race. And this is video 2. And in video 1, we went ahead and drew this, graph of each of the three racers. We also put slope triangles on there so we could see their rates of change, how fast they were going. So that we can see that the graph does show us that. And we looked at the start values. Now if we flip to the next page, we're going to see tables for each of the racers. So let's go ahead and label this as Leslie, Kristen, and Evie. And so let's talk about their start values. So Leslie, we're going to start a 0 here, and I'm just going to I'm going to go by ones for her. We'll talk about that why here in a second. So we'll just do 5, 6, 7, 8, 9. Let's go ahead and add a 10 on there. We'll just add one more row for her. All right, and what was her start value? Well, she didn't get a head start, right? She started at the starting line. This is what it says. So I'm going to put 0 here. Now, how fast was Leslie going? So just a reminder, this X, this is seconds. And this was meters, right? The Y was meters. And so she was going 2 meters every second, every 1 second. And so our table should reflect that. So if we increase this by 1 second, this should increase by 2 meters. And then if this increases by 1 second, this should increase by 2 meters. So I actually can build this table pretty quickly just by adding 2 all the way down. I'm going to put a +2 here, a +1, and that's the rate of change that we see in the table. So you can see right here, actually I'm going to put it on the other side, this arrow. This is the start value, and it's not because it's at the top of the table. This is the start value because X is 0. When X is 0, your Y value is your start value. And you can see the rates of change in the table. So once again, your change in Y, here's your Y column, this is the change. Your change in Y is 2 meters. And your change in X, this is your X column, is 1 second. Well, what about Kristen? Let's start here, and what was her start value? Well, she got an 8 meter head start. So her start value is right here. How fast was she going? Well, if we look back at the previous page, she was going 2 meters every 5 seconds. So here it would be a +2 meters, and over here it would be +5 seconds. So I'm going to add 5 seconds, and I'm going to add 2 meters. And so here we have the 0.510. If we go back to the first page, look at 5, go up here, you can see 10. Do that again. If you look at 5 and you go straight up to her line, if you go over, you can see 10 is there. What about the next point on her graph? Well, if you go to 10, you can see that it's 12. If you go to 15, you can see that the value is 14. If we go to her table, we can see those exact same values again. Increase this by 5, you get 5. Increase this by 2, 12. There's your 10, 12. Increase this 5 seconds. This is 2 more meters. 15, 14. And so these points will correspond with the points we saw on the graph. And we can keep going. So I'm going to continue just counting by 5s here all the way down. 30, 35, 40, 45. And this will be 16, 18, 20, 22, 24, and 26. All right. Now, the one advantage of a table over a graph, if you look here, our graph, we're kind of limited to how big we made the graph, right? We can go up to 32 seconds, and we can go up to 22 meters, but after that, we're off the graph. With a table, we easily could go past 32 seconds, right? So we have values that are definitely past 32 seconds. Let's take a look at our rate of change, our change in y over our change in x. So that is going to be our change in y was 2 meters, and our change in x was 5 seconds. So 2 meters every 5 seconds. And then EV. We'll start with 0 here. EV start value was at 6 seconds, or 6 meters, sorry. So she got a 6 meter head start. And then for her speed, it was 5 meters every 4 seconds. So when we build this, we're going to increase these by 4. So 4, 8, 12, 16, 20, 24, 28, 32, and 36. Yep, that looks right. And then this is going to increase by 5. So this is 11. Then it becomes 16. Then 21 and 26, 31, 36, 41, 46, and 51. Once again, these values go off the, like this point here is off the graph. And actually, all of these points are off the graph because the graph doesn't go higher than 22. So even though the x values are there, the y values are not. And then what was her rate of change? Change in y over change in x. The change in y was increasing by 5 meters. And the change in x is 4 seconds. So she's going 5 meters every 4 seconds. So that gives us a table for each of the racers. And once again, you can see the start values at the top of the table when x is 0. I forgot to write that here, start value. And you can see the rates of change, which is the speed of each of the racers, by looking at how much is the x, how much is the y value changing, how much is the x value changing, and it is change in y over change in x to find their speeds. All right, so now let's go down to the bottom part here. We had mentioned in the first video that we're going to look at 3 things. We're going to look at the graphs, we're going to look at the tables, and now we're going to look at the equations. So let's write down what we know about each of the racers. We know that Leslie's start value is 0, and her speed was 2 meters every second. Now I'm going to write that 2 meters over 1 second. I'm going to drop the units, and I'm going to simplify this fraction. 2 divided by 1 is just 2. So it's 2 meters per second. For Kristen, her start value was 8 meters. And her speed was 2 meters every 5 seconds, which I'm just going to call 2/5. I'm going to drop the units. And the reason I'm dropping the units, I'm getting ready to create an equation. And in an equation, we usually do not include units. And then we'll take a look at Evie. Evie's start value was 6. And her speed was 5 meters every 4 seconds. 5 meters every 4 seconds. So that is going to be just 5 over 4 if we drop the units. So in order to create the equations, this is what we're going to use. So you start with I'm going to start here at the end, but we'll talk about the start value. So with the start value, this happens once, right? So for whatever racer that is. So for Leslie, that's going to be 0. For Kristen, it's 8. For Evie, it's 6. And that number is by itself. Plus, you're going to take the speed times x. Now, x is the number of seconds, right? If we think about your x-axis, that's exactly what we had here at the bottom, time in seconds for x. And y is distance in meters. So let's go ahead and write that here, that x is time in seconds, just as a reminder. And y is distance in meters. Now the reason I point this out, we have all sorts of different values for these. Just look at our table, right? There's a bunch of x-y pairs for each racer. So there's a ton of them. But for for the speed and the start value, those are specific to the racers, right? Leslie has an absolute starting value of 0, right? There's no other value for Leslie. And her speed is 2 meters a second, right? So we know definitive values for Leslie. And same thing with Kristen, and same thing with Evie. So this speed and this start value, they are going to be specific numbers for each of the racers. Where the X and value change, the X and Y values are any number of combinations, right? There's a bunch of different possibilities. So when you write an equation, you put in the values that you know. Y is a bunch of possibilities, right? A bunch of different numbers, but we know her speed. It's 2. And then the next thing that comes as an X. I don't need to put the multiplication symbol here. I don't have to put a dot in between them. If I put 2 and X next to each other, if two things are next to each other, they almost always mean multiplication. So this is 2 times X plus the start value, which is 0. Now, I don't have to have that there because adding 0 doesn't change a value. So you could simplify this equation for Leslie to simply Y equals 2X. What about Kristen? Well, we can say Y equals, her speed is 2/5. 2 meters every 5 seconds. That goes here. And then her start value is 8. So that would be her equation. And then for Evie, 5/4 X plus 6. And so now you have an equation for all 3 racers. And equations are really powerful. And we're going to talk about that on the next page, because you can find a lot of different values using the equation that might be harder to do on a table or a graph. And we'll discuss that in the next video. So continue on to the third video.